very good morning, good afternoon, good evening to all my friends and the candidates and participants for this NPTEL MOOC course, the title of which is Application on Forecasting Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you can recollect, and by this time it would have almost become a known fact to all of you, that we are covering three main topics: averaging techniques forecasting, which is topic 1, topic 2 is basically regression models, and topic 3 is time series analysis. And we are in this 4th week, and the coverage, as you know, is still in the realm of averaging techniques and forecasting. This is 4th week, 19th lecture. What we plan to cover the coverage. So, if you remember in the last class I had just started discussing about Holt linear method, and I showed even if I gave you the concept of the trend and other things by drawing the diagram with data set D1, D2, D3 in three different colors. I said that considering we will take time, we will like to start afresh from this 19th lecture. So, Holt linear method, as already discussed, depends on the level at which you are starting and the trend, which is the overall average value of increase. By the way, I have denoted there is an increase for all the 3 data sets. It need not be increased, it can be decreasing also, or it can be fluctuating, but based on the fact I want to find out what is the average trend. Now, the formula would go like this. I will explain it and then utilize the Excel sheet to solve the problem. I will highlight them using orange color. So, the main task is to basically forecast. Here it is. And here, if you remember, there is an M. Now, if you remember in the last class I discussed that how many time periods you are going to forecast, or how many time periods forward you are going to forecast. So, if it is M is 1, that means we are standing today trying to basically forecast for the next day or next time period. I would not use the word day, because the time difference can be seconds, years, months, whatever it is. So, standing today T, we want to basically forecast for T plus 1. What does M not is equal to 1? If it is 2, it means that standing today, which is T, we are going to forecast for T plus 2. So, here T plus M means standing today T, we are going to forecast for T plus M. Now, what are the other terms? Term 1 on to the right hand side, which I will mark with red, is basically the level. That means from so called base point you are starting. And if I consider the second term on the right hand side, I will mark in green. There are 2 terms. One is B with certain suffix, with B would basically denote the trend, average increase. And if I consider M, it is the how many time periods you are forward you are trying to forecast. So, it will be multiplied. So, you will consider B as an unit increase or a unit trend per unit time. So, trend per unit time multiplied by the time frame would give you the total value. So, here if I draw the diagram, again I am going to use the y axis and the x axis, where along the x axis you have the time, along the y axis you have the values. So, if I plot all the 3 diagrams, one is red, one was green, and another I am considering as violet. Now, the starting point of the level for all these 3 are same. And if I consider B, it means basically the per unit change. So, if I divide into 2 time frames, consider this is T and this is basically T plus 1. It can be T plus M also. So, the trend technically would be, this is the base, this is the height. So, if I take the tangent, it will give me the tangent or the increase per unit time. That is why time M is being multiplied. Now, if I consider the level is given by LT for time period T, which is equal to so called, remember alpha is not the weight for forecasting, alpha is some other weight here. weight which is assigned to yt. So, alpha into yt minus, because the sum of the weights is 1. So, it will be 1 minus alpha, the level at time period t minus 1 plus bt minus 1. That means, at the level which was one time period before. So, if I consider the level, let me expand the diagram, in the sense the y axis I shift more onto the left and consider this is y. So, what I am trying to do is, and this is the previous time period. Say for example, this is t minus 2. So, I want to find out that at t minus 2, which is basically because no, sorry, this will be t minus 1, my mistake, t minus 1. So, I want to find out that starting at L t minus 1, if I consider, so from that position, so this is this position, from that position what is the increase? So, this value is basically given by B t minus 1 and this value is given by B t, that means increase trend per unit time, remember. So, the level would basically be alpha y t plus 1 minus alpha L t minus 1 plus B t minus 1. And if I want to find out the trend, it will basically be the difference in the two levels L t minus 1 multiplied by beta plus 1 minus beta into the value of the trend one time period before, which is B t minus 1. What are the nomenclature for this Holt linear method? They are exactly the same, but I will still repeat and I tick mark as I proceed. Y with the corresponding suffix is the actual value, F with the corresponding suffix is the forecasted value, E with the corresponding suffix is the error, which is the difference between Y and F. L with the suffix T estimates the level of the series, which is basically a type of smoothing value. So, from well level which you are starting, and BT, as I said, is the trend estimate of the slope of the time series. So, there are two things, one is L, which is for the level, B, which is for the trend. So, we will assign a weight alpha to the level. It's again I am saying alpha is not the weight which you are assigning to the forecasted value or the predicted value, as we have seen till now. Beta is also the smoothing constant for the trend, and as usual the weights are between 0 and 1, and the weights which, in case if we have more than 2 time periods to consider, the sum of the weights for the level should add up to 1 and sum of the smoothing constant for the trend should add up to 1. M is the number of periods ahead you want to forecast, and alpha beta are such that the sum of the squares is minimized, that means whichever metric we are trying to consider. Now, this is the data which you have, and I will basically go to the Excel sheet to solve it. So, here is the Excel sheet. So, I will use the Holt linear method. This is alpha. Alpha has to be given, based on which you will try to find out the error. Beta is the value. So, alpha and betas are the corresponding weights which are given for the level and the trend, alpha, beta. M is the number of time periods ahead you are forecasting. So, I will consider M as 1, because till now we have considered for all the problems. The standing today you are trying to basically predict for the next time period. That means, for given yt and ft you are trying to utilize all the data which is in the past along with yt and ft basically to forecast for the next time period, which would be given by ft plus 1. So, starting January till December, you have 24 data points. The y values are given, as you can see. By the way, this Excel sheet would be shared along with the PPT, so you need not worry. Now, let us go one by one what we need to do. Very simple. Now, if I consider, so the value of LT LT is basically the level you are starting. So, we will consider the LT value for time period T as exactly equal to the actual value for YT. Hence, this is 143 as you can see, and this is very intuitive because from where you are going to start level is exactly the value which is there and which is given from the actual data. So, if 143.11 was 169, so LT and the shaded area. So, if you remember in the other slides or the Excel sheet, I used dark blue to highlight the values which were being assumed and put. Here I am basically highlighting the cell as light blue color. So, it is easily discernible and you can understand. So, basically the cell value C153 is exactly equal to the value of B153 because you are considering LT as the being utilized, which is the waste value being YT. Now, what becomes B? B is the average increase. Now, a very simple case can be like this. So, if I want to find out the average increase, rate of increase. So, consider I have the past data. In case the past data is not there, I am considering that this will be replicated. So, the past data is being mimicked in the data set which you have. So, here if you see the average value 189. So, and if it is 189, that means if I consider per unit time. So, per unit time difference is what? So, this is I am going a little bit slow, but I am sure you will understand. So, the difference between February and January is given, which is 9. So, per unit time per month. So, if I calculate these values, so they come to be 9, 22, minus 22, minus 2 and all these things. So, if I find out the average of this, I can take that value comes out to be about 5.3. So, I can take the say for example, trend to be 5.3 or about 5.5. Now, why did I take 9? The reason being, which may not be absolutely 100% correct, but I took basically the average of the difference between January and February per unit time comes out to be 9. I can change it, it can be 5.5, 6.5 depending on how the data set is. Now, I start the calculation. So, if we remember, I need to find out L, I need to find out B, then I need to find out F. So, first I need to find out L. So, the L value is B 151. So, the value in B 151 is the alpha value. So, let me go back to the slide also. So, there is no confusion and there is no ambiguity in your mind. So, it is basically alpha into YT. So, B 151 is 0.6 alpha into YT basically comes out to 152, which is in cell number B 154. 1 minus alpha 1 into the difference. Now, what is the difference? LT minus 1, BT minus 1. So, LT minus 1 is given in cell number C 153, which is 143 minus BT minus 1, which is 9, which is given in cell number D 153. So, utilizing that, I have 144.80 as LT. The next value for the trend BT is given by beta into LT minus 1, that is the level for this period minus the level of the last period. So, that value comes out to be beta is given as 0.1. So, 154 minus 153 of C column is exact and 1 minus beta, and what is the last value you will multiply is BT minus 1. So, BT minus 1 is given as 9, I basically find it. So, basically this is BT, which is cell number which we calculate is given in cell number D 154. And finally, the forecasted value. Now, remember I am taking M as 1 So, if it is m as 1, I go to the formula which is the third point which is highlighted in this PPT slide. It is LT plus BT into m. So, what is LT? LT is given by 144. So, this is given by, and it is one period backward. So, basically it is LT, because I am trying to forecast for FT plus 1. LT is 143 plus, here you have basically the value of BT minus 1, which is 9, into the time period difference, which is basically 1. So, I have 152 value. I copy these values which I have done, and I find out the values of forecast. Now, let us basically first, just for information, let us plot the values. So, actually I will be utilizing the B column values and the E column values. So, the month is given, I will utilize all the values and I take everything and then delete the corresponding irrelevant set of data, such that we are only able to highlight YT and FT just for the timing, and then you have to find out the error. So, this is the, so YT is required, LT is not required, which is the orange one. Let me try to delete it. So, it is done. BT is basically the value which is for the, this is a, so now you have YT and FT, which is the actual value and the forecasted value. So, let us check that how the value changes, the graph changes as I change the values of. So, let us take alpha as point, say for example 0.7. So, YT changes, it changes, just check. If I change beta as, say for example 0.5, FT will change. Obviously, FT should change because that is the forecasted value. So, let me make the graph a little bit more elongated one. So, it is easy discernible by all. M will not change because M is the time period. So, basically I will keep changing. Wait, let me put it in the frame such that we can see all the, so done. So, let us take beta as, say for example 0.9. The F value changes. F value is basically the yellow one. If you need to make it much more visible, let me change the color to red and let me change the width of that. Let me make it 5. So, this is the blue one. Let me make it dark blue or violet, and let me make the value also of 5 units. So, done. So, basically the red one is the forecaster. So, let me change beta as 0.4. There you see the forecasted value. Let me check, I am changing them, but at what value it will give me the optimum value, I have not come to that. So, let me check it, change it to 0.2, the red one changes. Let me check alpha as 0.3, the red change. So, if you see, for alpha decreasing, it more becomes a trend line as it should be. Why? So, if alpha is almost 0, what you are trying to do is that give all the weightages to the difference in the previous level and the trend. So, that would basically be a smooth line, because you are basically eliminating the effect of the actual value, which is YT. Say for example, I take alpha as 0.1 straight line. If I take alpha as 0, so, it is basically straight line, because all the y values affected are being taken out. So, let me take it as 0.4 back. So, this is the value. Now, what values alpha and beta would you take? So, I will delete this graph. So, I will take the error and the error is basically the difference between the actual value minus the forecasted value. Actual value is given in column number B and the forecasted value is given in column number E. So, difference I find out and I have this difference. So, this is the difference. So, if needed we can just plot the error, and here if I see the average comes out to be 12.8 or actually the average should be 0, but given the data set which you have, if I plot it just for our understanding, this is the error how it looks like. Along the x axis is basically the time frame starting from February, March, April, so on and so forth, and the green line fluctuation is the error. So, it fluctuates to maximum of plus 40 and goes to a minus values of about minus 10, a little bit below here. Now, let us find out which method would be the best. So, if I see, I will use the minimum absolute value. So, if I keep changing, you will find it out. So, minimum absolute error and the sum of squared error, I am only utilizing 2, I can extend that accordingly. So, mean absolute error, okay, I will use the sum of the squares, not the idea is the mean of the sum of the squares of the errors, and also I will use mean error, both. Mean error is basically sum of all the errors divided by the number of reading. So, that would be equal to the sum of all the errors and if you find out how many such readings are there, let me basically double check once more. There are 23 data points because the January 1st data is not there based on the fact that we are starting at that value. So, it will be divided by 23, mean error. So, this is about, if you remember I mentioned 12.8, it comes out to 12.799691 because the decimal places in this H column is still 6 places of decimal. Now, if I find out the mean absolute error, so I need to basically find out the sum. Now, I can do one thing, I basically find out the error, all the absolute values, then add them up. So, basically I will, no, let me put it because I need to change the values of alpha and beta and illustrate. So, it may take a few minutes more, but I will still proceed accordingly. So, this is the sum of the absolute values of first absolute value of F155 plus absolute value of F156 plus absolute value of F157 plus absolute value of F158, absolute value of, oh, there is a plus, absolute value of F159. So, how many values are there? Let me put it and then I'll come. I'll tell you what I am doing, you will understand. So, there are cells starting from 154 till 176. So, let me copy it and make it in. So, this is 154 till 176. So, here I do. So, this is I am going to do, I just zoomed it. So, we will go to 176. So, this is 159 value is there, plus 160 value is there, 161. So, I have to keep adding till 176. 162, 163, 164, 165, 66, 67, 68, 69, 70, 71, 72, 73. So, I need to proceed till 76, 74, 174. So, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75 and 76. Now, all these sum is there. So, I found out the sum. I need to divide by, because it is the mean absolute error, I need to divide by 23. So, I divide the sum. So, if I put it here, so this would go to, this would go here. So, the value is 16.899273. Finally, I need to find out the mean sum of the square errors. So, mean of the sum of the square errors would be the absolute errors, or the errors are just multiplied. So, I can basically, so I find out the sum. For simplicity, I will just make the thing much clear. So, this is absolute error being squared, absolute error not being there, because I am just squaring the error. Error is given in, if you remember, in column F. So, I will take a little bit more extra time to basically highlight. So, I go to, I am just squaring all the errors, I am removing the absolute terms, so that when you check the formula in the Excel sheet, there should not be any confusion amongst any of the participants or the students for this course. You can also do these problems very simply using any coding concept of R and MATLAB, but I am trying to avoid that. Even though for any detailed analysis of a problem, I would definitely do that using any MATLAB or R. SAS is there, other Statistica is there, SPS is there, all they can be utilized. So, I find so, I am trying to now square the value of one's error in 170 F170, which is the error given in that cell. So, I am going to basically find out the square of cell number 171, 172 already done, sorry, 173 already done, 174 done, done means square done, 176. So, I need to find out the sum has been found out, and then divide by 23, because 23 is the count of such values, the average needs to be found. So, I put it in this cell which is MSSE. So, it is a square value. So, I need to basically put the standard in case needed. Let me put the square root also. So, the square root of which is the, I will put it here, not the mean square error, I will put it the SQRT. Remember SQRT, just a short form for square root. So, here I have, so I will basically highlight it in bold and make the first one as, say for example, yellow, second one as, say for example, orange, and the third one as light green. Mean absolute error, square root of mean of the value of sum of the square of the errors and mean error. So, these are the values 16.89, 20.20, 12.79. So, if I consider the concept, if I am going to compare the models. So, for this model, for these values of alpha 0.4, beta 0.2, the values are this. Let me check if alpha 0.4 is changed to, say for example, 0.8. So, the value comes out to be 14.85 for mean absolute error, square root of the mean squared error comes to 18.5 and mean error comes to be 12.39. If I change the values of beta to 0. Say for example, 7. So, the corresponding values, if you see the yellow, orange and green are changing to 17.8, 21.2 and 22.9. If I want to change alpha, make it low, 0.2, the values comes out to be 26, 31, 41. I am not reading the decimal place. So, with this you can basically solve many type of problems. This is the Holt linear method with m is equal to 1. Now, question can be, can m be increased to 2? Yes, it can be, but the data set should be large. Or can we have Holt linear method with I have more than one alpha, more than one beta? Yes, it can be. But considering the complexity of the problems you want to make, these set of models which you are considering are more than enough to help you to solve problems and get a very good grasp in the forecasting technique. With this, I will end this class. It extended considering that the Holt linear method had to be explained in the Excel sheet. And thank you very much for your attention. Have a nice day.